Welcome to the Idea to Value podcast, where in every episode we highlight the latest insights into creativity and innovation from experts around the world. I'm your host, Nick Skillicorn. I care about the evidence behind what makes ideas happen, and I've already helped thousands of people just like you through my unique insights into recent scientific findings of how creativity works. I also show you how to turbocharge innovation programs so they finally deliver on the value and ideas you've been struggling to execute. Get your free training on how creativity can be improved by registering now at www.ideatovalue.com. Now let's get on with today's episode. Hello everyone and welcome to another Idea to Value podcast interview. We've got a very special scientific mathematical one for all of you geeks out there today. I'm very happy to have Professor Lav Varshney with us today from the University of Illinois, and we're going to be talking about the mathematics of creativity and how that feeds into a lot of the artificial intelligence-based creativity that's really taking the world by storm nowadays. Professor Varshney, it's wonderful having you here today.
Yeah, Nick, it's great to be on your podcast.
So for people who haven't heard of you before or know what sort of work you do, can you give us a brief background as to how you got to where you are now and what the interest in creativity has been?
Sure. My doctoral work at MIT was focused on information theory, where I was trying to understand the fundamental limits of communication in various settings. So proving mathematical theorems that tell us what's possible and what's impossible in communication. And after that, I joined IBM Research, and I was there for some years. And as researchers, we were charged with brainstorming on ideas to do something pretty grand after IBM won on Jeopardy. And so I thought creativity is really a good next step after inductive reasoning, like was featured on Jeopardy. With deductive reasoning, like chess, you have all the pieces on the board. With inductive reasoning, you have to make some inferences, but with creativity, you're trying to create things that have never been imagined before, computationally. And it seems kind of strange that computers would be able to do this, but we wanted to push in that direction. And so I started this project called Chef Watson, which was focused on the culinary domain. And we built a system that could generate novel and flavorful recipes automatically. And we tested them pretty extensively with chefs and had banquets and food trucks and cookbooks and all kinds of things. And that worked pretty well. And since I've moved to the University of Illinois as an assistant professor, I've been going back to my roots in information theory, asking what are the fundamental limits of creativity? Are there similar limits like there are in communications? And this is very interesting from a scientific perspective because it raises the natural question, the systems that we built at IBM or that Google have built or others have built, are they close to those limits or is there a lot of room for improvement? One can even ask, are humans close to the limits of creativity or are we far away from those limits and how can we improve?
And for anyone who hasn't heard of Watson before, there's probably a couple of people on the podcast who know all about IBM's Watson computer, but some probably haven't. What was Watson and sort of what made it different from previous supercomputers?
Right. So Watson actually is a whole suite of different technologies. There was the Jeopardy playing Watson, which was concerned with question answering, natural language processing, and so on. And then my project was focused on computational creativity, which was completely distinct technology. And there we were ingesting existing recipes, data from the chemoinformatics of food, so which flavor compounds are in which food ingredients, the psychophysics of human flavor perception, so which compounds do people like and dislike, a variety of other data sources, using that to develop models of human novelty perception, of human flavor perception, and so on. And then we were generating, say, millions of recipes and then picking the best ones using these psychophysical models, and then eventually creating recipe steps so you can actually cook, and proportions as well. So creating complete recipes.
I remember many years ago reading about Chef Watson. I don't know if it was in Wired. It probably was in Wired, but they highlighted one recipe which no one had thought of before. I think it was some sort of chipotle sauce with random ingredients.
Yeah.
And it's one of the first examples that I think the mainstream press picked up on about something that a computer system had been essentially completely creative in generating that humans have had millennia to try out but just hadn't discovered before.
Right. I think you had probably seen the Bengali barbecue sauce using butternut squash.
That's the one.
Yep, which was really good. And another recipe that was in Wired was a Caymanian plantain dessert. So that had a banana cream layer at the bottom, a lime and coconut layer, and then a papaya salad with cayenne pepper and plantain chips at the top for some crunch. So that was a really good recipe as well. That's one I enjoyed. And in fact, my wife and I, we served it at our wedding reception.
Oh, that's lovely. Now, what I think a lot of people are probably scratching their heads about now is, how can you claim that a computer actually did something creative? Because isn't creativity an innately human trait? Computers are great at computing things and searching for things, but creating something new, they can't possibly do that, can
Yeah, it's an interesting philosophical question how we should define creativity. And there's different views on that. And of course, creativity is often cast as the pinnacle of human intelligence, kind of our defining glory in a way. So it is sometimes problematic to cast computers as doing that. But we essentially operationalize the definition in the way that psychologists who study creativity do, which is to say that we think of an artifact or an idea that's generated as creative if it is both novel and high quality in the domain. And any system that can create such artifacts or ideas we will call creative, whether it's human or machine. We're not delving into the kind of question of self-reflection or motivation or things like that that people often think about when they're discussing human creativity. We're kind of taking the very precise psychological standard of novelty and quality.
It depends who you ask. Some people use the phrase new and useful. Some say like unique and valuable. And I think you're defining it slightly differently, defining it on quality. And what's the other criteria there?
Novelty.
Yeah, so it is novelty and quality. So again, it lines up very much with the way that the creativity researchers of the world are approaching the subject.
Yeah, exactly.
But one question then again, asking about how computers can be creative. Essentially, if you feed this computer a data set, are you just asking it to try out random combinations? So it's a kind of brute force creativity where it'll spit out essentially any calculated combinations it can come up with, and then does it require a human to sort through them to figure out this one's new, but it actually has some quality to it as well?
No, actually, if you think of the culinary domain as an example, and you just look at ingredient lists, there's about 1,400 ingredients that people commonly eat. And so there's 2 to the 1,400 possible combinations of those ingredients. And that's astronomically large, right? There's no way you could search through all of those, even with a supercomputer. And so what we've developed are algorithms that are generative, that create new ideas through some sort of stochastic sampling, kind of some randomness, but inspired largely by existing human recipes. So we have an inspiration set that gives us inspiration, and we riff off of those essentially, recombining things, mixing things, and so on. And so then we'll get maybe 1 million ideas or 10,000 or however many ideas we care to generate. But then the key to this whole business is not just generative but selective algorithms. The ability to predict what will actually be flavorful or not, separately from human judges. And that's really what gives power to the machine. Because actually 1 million new recipes is not so useful to you. The 3 best ideas are what are actually useful to you. And that's what the algorithms generate.
Absolutely. I think that's where we're starting to actually see progress in the world of artificial creativity, as I say it. Because you can set a computer to combine random words together and it'll do it until the end of time. But eventually you need to start giving it ways of assessing whether or not something has quality and therefore might be creative itself as well.
Right. That's exactly what we were aiming for. If you look at earlier examples of computational creativity, like Doug Lenat, his automatic mathematician, it would give you theorems in logic that were true, but he would have to figure out which ones are actually interesting to people. Or Harold Cohen from UC San Diego, he had a painting system called Aaron, and Aaron would generate maybe 300 paintings overnight, but it was Harold who would in the morning pick which ones to actually print and send to the gallery. Here, the whole innovation is using large-scale data to be able to predict and model human perception to say that these are the 10 best things, and here's a ranking of them, and so on.
And I'm really keen to get onto that sort of aspect of where we are nowadays with the quality of output of artificial creativity. But I want to just go back to one thing you mentioned earlier, which is this mathematical framework around creativity. Because there's obviously people approaching creativity purely from a human perspective, seeing how humans are creative, what's happening in the brain, what's happening when they're put in different situations. But how are you currently focusing your time and your attention on studying creativity?
Yeah, so in addition to the culinary work, we've also been looking at a variety of other domains to actually build algorithms in fashion and in material science and in education to create engaging learning experiences for students. But within the mathematical theory, we've been asking what is the best that any system could do? We have some approaches for building systems. Others have various algorithms for generating creative artifacts, whether based on genetic algorithms or neural networks or association or all kinds of different algorithms. But we want a common framework to be able to compare all of them. What is the best that can be done by any system that's being created? And what we've done is established a mathematical framework. And so we define precisely the notion of novelty, the notion of quality, the space in which you can be creative, which is defined by the set of ingredients or the parts that you can combine to create new artifacts, as well as the set of things that are already known, the inspiration set. And using those 4 or 5 kind of formal mathematical statements, we can now generate a theory to say what's the fundamental trade-off between novelty and quality in a given creative domain. As you can imagine, it's easy to be novel but low quality. You just put random stuff together. And it's also easy to be high quality and low novelty. You just look stuff up in your favorite cookbook. But the tension is to do both simultaneously. And what we're able to prove is that there is a fundamental trade-off between the two. And that emerges essentially from an analogy to other branches of engineering theory, like information theory or thermodynamics.
So you're saying that from a computational creativity aspect, the quality and originality or newness are inversely proportional. Is that always going to be the case?
There's a relationship that says that one is a function of the other. It's not exactly an inverse relationship. It is possible to push beyond just a simple linear trade-off, and that's where very high quality creativity actually happens. But yeah, that's the kind of the basic result, that there is a basic tension between these two dimensions.
So are we moving into a direction now, if you're saying that there's not necessarily always a trade-off? The way that technology nowadays is going, and I don't know the answer, I'm really excited to hear your opinion, but if you think about it using functions that people might be familiar with for everyday computing, if you were to want to have a button that says create and have 2 sliders, one for quality and one for originality, does one always need to go down if the other goes up, or would you eventually be able to just say set them both to 100, click create, and you get the next piece of Shakespeare out?
Yeah, so even Shakespeare couldn't do 100 on both. That's the insight from the theory, that when you set one counter or one dial up, it does force the other one to be a little bit down.
And do we have now a feeling from the mathematical aspects where the ideal ratio is, or is that something that's just...
It's a full trade-off curve, so you can go from fully novel and fully not high quality all the way up. So you can trace out that whole trade-off curve, and there's different settings where you want different trade-offs. When you're doing public demonstrations of culinary systems, you typically want the novelty to be quite high and the quality maybe a little bit lower. But when you're cooking at home, maybe you want the quality to be as high as possible, quite high, and the novelty is not so much of a concern.
It's really exciting times, and I look forward to seeing what's happening in the future. But let's get back to what's happening nowadays. There's more and more technology is being displayed that some people might not be aware of, but that people in the industry find really exciting. So one example of artificial creativity which people can actually use nowadays is music generation. Sometimes for some of my short videos, there's a free online tool called JukeDeck, where you can set some small criteria about whether or not you want the music to be sort of classical or jazzy or piano-based or more sort of rock and roll, and the duration you want it to last, and you click create and it'll generate a song. And if you click it create again with the same criteria, it'll generate a completely different song, and every time it's completely unique. And this is generating music that previously people would have associated only humans can produce. It's quite an exciting development.
It is, yeah. So there is of course a history to this. People have been working on artificial music generation for maybe 30 or 40 years, perhaps even longer. But some of the new results that are coming out from, say, Google Magenta or other from Sony and from some other research groups, they're quite fun to listen to. I actually listen to them sometimes myself. And some of those technologies are actually using neural networks, so-called deep learning, to learn, to model the nature of music, and then use the models in reverse to do generative things to generate new music. One of the difficulties with deep learning is that it's not very interpretable. The neural network models that come out of training are hard to interpret. So it's hard to essentially parameterize what's going to happen. You can do a kind of mix jazzy with classical, but you can't say I want it specifically like Bach or specifically like Beethoven or Mozart, or this aspect of Mozart and this aspect of Bach. And that's what's suggesting some new research that my group is doing on concept learning. What we're trying to do is take music and essentially learn the laws of music theory from it automatically in a human interpretable form. And if you can learn the laws of music theory from, say, Bach's chorales, you can then generate in that way. Or you learn the rules that are present in certain pop music. You can essentially have a new music theory for that, and then use that to generate new music. And then it'll become much easier to parameterize and specify what kind of thing you want. And that's one of the things we're working on right now.
So outside of music, are there any other examples of computers generating things that could be considered truly creative works that you think should be more widely known nowadays?
Yeah, so I think there's a lot of work these days in visual art. And so there's paintings that are computers, animations, or all kinds of things in visual art that are becoming very good. And then there's also domains that are not considered so artistic typically, but that require a lot of creativity. So things like engineering and science and so on. Culinary is kind of in between. And there's a lot of growth in computational creativity now for these kinds of domains, largely in supporting humans, but also acting on their own, whether it's building new bridges or developing new materials for say metal alloys. That's a surprisingly down-to-earth problem, but where you can still be creative. Copper and iron and silver and zinc, you can still mix them in new ways that people over the last 5,000 years have not thought about yet.
And I think engineering is a fascinating thing, because when you combine these programs that can generate designs, if you set them, and my understanding is if you set them a set of criteria that their design needs to meet, they can then test out all of the structural aspects themselves, and then if it passes the criteria, you can now cheaply try out a prototype on a 3D printer and get results that no human would ever have thought of.
Yeah, that's right. I think there's a lot of exciting things going on in engineering.
What about aspects of creativity that computers really struggle with? What sort of examples do you have of that?
So I think one of the things is when you model things computationally, or when you kind of cast things mathematically, there's almost by definition things you do not model. So to take the example of culinary, since I've been working on it for some time, If you don't model things about the sound or the color of food, for example, you might end up with things that are not visually appealing if you're only focused on the flavor and notions of novelty. So you might end up with a Midwestern mushroom stroganoff that's just brown colored and not very appealing. So it's largely about what you're modeling. And the other aspect of creativity that's very hard to do computationally is what people call transformational creativity, providing completely new views or frameworks for thinking. Some of the greatest advances in human history have been this kind of transformational kind of creativity rather than so-called normal science, kind of a normal kind of creativity where you take existing things and recombine them in new ways. So that's the other style of creativity that I think has been very challenging computationally, to completely change worldviews because there's not even a language to describe how to encode that.
So you're suggesting that if you get all of the inputs and all of the criteria perfect, as you said, you could teach a program to develop a piece of music by Bach, but a piece of music, that same software could never then invent a new style of music like jazz.
I think maybe in the future, but I don't think we know how to do this currently.
I think a lot of people are really excited by that idea, but at the same time, there's probably some people who think, yeah, I'm not quite ready for the Terminators to come and take over yet. But
yeah. And actually, like what I've been finding in my experience is that some of the most creative things emerge when we combine human creativity with machine creativity. When you allow the machine and the humans to have conversations, essentially. Let the human impose different constraints than the human would naturally, push them into new boxes, and let them do their thing. So that's kind of the combination of the two is actually quite powerful.
Have you got an example of that?
Yeah, so in most of this work we do in all the application domains, we've been working with human experts. And so we will give them perhaps not a complete recipe, but just the list of ingredients and the name of the recipe, and then they'll develop techniques themselves, or with education, we'll develop kind of the framework for how to teach gravity using experiments, but we'll let some of the specifics be developed by science teachers. So in all of these examples, it seems that there's some value in bringing the human and the machine together.
I look forward to seeing where the technology takes us in the next couple of years. Professor Varshney, it's been absolutely fascinating speaking with you today. If people want to find out more about the subject or about the work that you're doing, have you got any resources that they can check
out? Sure. If anyone wants to go to my research website, it's www.varshney.csl.illinois.edu. There's links to papers and other materials. So I'm sure people can check those out.
Absolutely. I'll get all of those links down in the description below. And I just want to say again, it's been absolutely wonderful having you here. I've really enjoyed our conversation, and I look forward to speaking again with you soon.
Yep, sounds good, Nick. It was fun for me as well.
Today's episode was made possible by members of our premium Deep Creativity Training Program. For less than the price of half a candy bar per day, you too can get world-exclusive daily exercises which push your creativity past its comfort barrier to make you better able to generate ideas in all aspects of your life and work. Invest in yourself now by going to www.ideatovalue.com/deepcreativity and using coupon code PODCAST for 25% off your first order. And don't forget that if you found this episode interesting, to like and share it, and to leave us a review in your favorite podcast player. See you again in the next episode.